Hi guys, Miss Valero here. Just going to walk you through some practice problems on compound probability. Compound probability being that there is more than one event taking place. Simple probability would just be the one event. So each of these problems are going to have more than one event taking place. And I'm going to show you a new way to write the event as well, maybe something you haven't seen yet. So let's get started. Here we have the first problem. There are two jars. One jar has 2 orange marbles and 3 red marbles. The other jar has 1 blue marble and 4 green marbles. If Jeff randomly draws 1 marble from each jar, what is the probability that he will draw a red marble and a green marble? Okay, so we're looking for a red marble and we're looking for a green marble. I'm going to write that as capital P for probability. My event goes in the parentheses. We're looking for a red and a green. So another way to write, instead of writing the word and, is to use this upside down U. That stands for the word and. So we're looking for the probability of a red and a green, which would be the same as finding the probability of just the red first and multiplying it by the probability of the green in the second event. Now these are independent events because the one marble selection does not depend upon the first marble selections, being in that they're 2 separate jars. So let's find the probability of the red event. We know that in the first jar there are 3 red marbles out of 5 total, so that's 3 out of 5. And then you would multiply it by the probability of how many pulling a green marble from the second jar. So the second jar has 4 green marbles. So that's 4 out of the 5 total marbles in that jar. Since it had 1 blue and 4 green, that's a total of 5. 3/5 times 4/5 equals 12 over 25. So that's letter A. Okay, let's try that again. Number 2. Here we have an experiment and it's broken up into 2 parts. The first part of the experiment is a 6-sided die is rolled. The second part of the experiment, a dime is tossed in the air. What is the probability of getting a 4 and heads? Again, they're independent events because the one does not depend upon the other. So we're looking for the probability of a 4, and then there's my upside down U for and then we're looking for heads. So because they're independent events from one another, we're just going to multiply the probability of the 4 times the probability of getting the heads, which is going to be the same as the probability of 4. Let's think about that. How many 4s are on a die? Well, there's only 1. And then there's 6 possible total numbers you could get when you roll a die. So 1 out of 6. And then you're going to multiply that by how many heads there are in a dime. There's only 1. Anybody know what president that is? And that's going to be out of 2, as the other side's tails. When you multiply that, you get 1 out of 12, which would be answer C. Make sure you simplify your fractions. Oh, sorry, number 3. Okay, this is like number 1. It says again, there's 2 jars. One jar contains 2 red gumballs, 3 green gumballs, and 1 yellow gumball. The other jar contains 2 blue balloons and 3 purple balloons. Jeff randomly draws 1 gumball and then a balloon. What is the probability he will draw red and blue? Okay, so we're looking for the probability of red. And again, they're independent events because they are in separate jars. There's 2 of them. So we're looking for the probability of a red from the first jar and then the blue balloon from the second jar. So the probability of the red times whatever the probability of the blue balloon will be. If we count up the red gumballs, we know there's 2. So that's 2 out of how many total? We have 2 plus the 3, that's 5, plus the other one, that's 6. So that's 2/6. And the blue balloons, we have 2 blue balloons and 3 purple balloons. So that's 5 total. And we're looking for the blue, and there's 2 of them. So that's going to equal, these can be simplified by cross root reducing. That's going to be 1, that's going to be 3. 2 times 1 is 2. 3 times 5 is 15. So the answer is 2/15, which would be A. Okay, let's move on to number 4. Okay, in number 4, we see Bob has a coin cup and it has 4 $1 tokens, 2 $5 tokens in it. He also has 2 $10 tokens and 1 $25 tokens in his cup. In his pocket, in his pocket. He randomly draws a token from the cup and then randomly draws a token from his pocket. So they're independent events, the first one being from the cup, the second one being from his pocket. What's the probability that he draws 26 in tokens? Okay, so we need to think to ourselves, how can we get 26 if he's drawing from his pocket and from the cup? Well, if you look at the cup, it has $1 and $5 tokens in it. And then if you look at his pocket, it has $25 and $10 tokens in it. So I know that in order to get 26, that's 25 plus 1, right? So I'm going to just change this question to read, what's the probability of getting $1 token? Sorry about my handwriting on here. And $25 token. Because there's 2 events happening. He's drawing from his cup and from his pocket. Okay, so we're looking for the probability of a $1 token, and there's my and sign, a $25 from the 2 separate events. Okay, so the probability of getting a $1 times the probability of $25 token. Well, let's go back to his cup, coin cup. He has 4 and 2. So that's 6 tokens total. And how many of them are 1s? 4 of them. So the probability of taking a 1 out of his coin cup is 4, like how he keeps the higher ones in his pocket. Okay, and then we have the probability of getting a 25. So if we go back to his pocket, he has 2 10 and 1 25. So there's a total of 3 tokens. And out of the 3 tokens, only 1 of them is 25. So if you multiply those up, and there's nothing we can cross reduce, we have 4 out of 18. And if you simplify 4 out of 18, that's what, 2 9ths. So my answer should be 2 9ths. You will look over here. There it is, letter D. Good. Let's go on to number 5. Okay, here I see an array of 2 die, and it looks to me like these numbers are the sums. And if you remember, how you get the sum is by adding the first die to the second die. Okay, so an experiment consists of rolling 2 fair die and adding the dots on the 2 sides facing up. What is the probability that the sum of the dots is divisible? We're looking for sum is divisible by 3. Okay, so we're looking for our probability is that the sum has to be divisible by 3. Okay, so these are all the sums. I've already done the array for us, which is really nice. So now we just need to figure out which of these sums are divisible by 3. I know that 3 is divisible by 3, so both of these. I know that the next number divisible by 3 will be 6, so all of these sums will be divisible by 3. And then I know that 9 is also divisible by 3, and lastly 12. And if you haven't done an array yet, in order to get these sums, you would just take the value of the die up here, first die, let's say this one here is 3, and we would add it to the sum of the number value on the second die. Like say if we did 3 times plus 2, and you would get that value right there, 5, because 3 plus 2 is 5. So if we look at this one over here, 5 plus 3, you would come down 5 and come over 3, and you'd put the value 8 right there. Okay, so we're looking for the probability that a sum is divisible by 3. So if I count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's 12 out of how many total? Well, it's 6 by 6, so that must be 36 total. And 12 divided by 36, if you simplify that, that is 1/3. So the answer should be 1/3. Let me look at my answer choices. Yep, letter C is correct. Okay. I'm going to stop the video here and conclude part 1, and then we will do part 2 will be numbers 6 through 10. So if you have time to do those as well, you can look at that one next. Thank you for joining me.